Question number 5, it says we spend 60 days of summer vacation to travel 6,300 kilometers across Canada. So the one-way trip is 6,300 kilometers and the way back is 6,300 kilometers. So by the time they reach Halifax to return home, they realize they have to travel 72 kilometers a day farther each day to make it home in time for school. So if we let x be the rate in kilometers per day to travel to Halifax, we write a rational expression for the number of days it takes to travel to 6,300 kilometers to Halifax. So if we were to write that for part A, we have our total distance divided by velocity will give us the time. And so the distance is 6,300 kilometers to Halifax, and the velocity is x kilometers per day. So that in red represents the solution to A, the number of days it takes to travel to Halifax. The number of days it takes to travel back from Halifax to Vancouver is going to be the second part here. So the total distance is still 6,300 kilometers, so distance divided by the velocity. In this case, the velocity has to be increased by 72 kilometers per day. So we have x plus 72 as the velocity, and that represents the number of days it takes to travel back to Vancouver. So we have a total of 60 days to do this. So when we add these together, we get 60 days, and that represents the equation to solve for the rate at which we are traveling to Halifax. So x represents the original rate. So we can then go ahead and solve this equation. We're going to eliminate the denominator. So x cannot be equal to 0 kilometers per day or negative 72 kilometers per day. Those restrictions really aren't that significant in this problem because that's not likely. But now we're going to eliminate this denominator. So I'm going to multiply by x and x plus 72. Okay, I'm just going to do it off to the side here because we're going to end up with, I need some room to work here. So it's going to be 60 times x plus 72. Okay, nothing cancels out on the left-hand side. On the right-hand side, we're going to be left with 6,300 in the numerator, and the x's cancel out, so we're going to end up with multiplied by x plus 72, which doesn't cancel. For the second part, plus, we're going to be left with the 6,300 kilometers in the numerator, and this time the x plus 72's cancel out, so we end up with x. So there's our equation. I'm going to solve that equation. I'm going to expand that out. So in this case, I'm going to end up with 60x squared plus 60 times 72 times x. So 60 times 72 is going to give me 4320x. And on this side, we're going to end up with 6,300x plus 6,300x is 12,600x. And then the 6,300 times the 72 gives us 453,600. Okay, so then I'm going to make this equal to 0 and solve using the quadratic formula. So 60x squared minus, so it's going to be 4320 minus 12,600, and we end up with negative 8,280 x's minus 53,600, and that's equal to 0. Okay, just checking to see if we have a divisor of 60, and it looks like we do, so I'm going to divide out the 60 or I'm going to factor it out. So I end up with x squared minus 138x, and then divide that last term by 60. I end up with minus 75. 60 equals 0, and then that's likely factorable, but I'm just going to plug that into the quadratic formula. I get x is equal to 138 plus minus the square root of 138 squared. That's going to be 19,044 minus 4 times a times c, and that's all over 2. Okay, so plugging that into my calculator, these are kind of big numbers, so it's taking me a while to plug this in. And it looks like I have 180 as one solution, and the other solution is negative 42. We know that that is not a valid solution. So the original velocity is going to be that we're traveling per day was 180 kilometers per day was the rate at which they were traveling to Halifax. On the way home, it would have been they're traveling at a rate of 252 kilometers per day.